Alright, so hello and welcome back to the series, and in this episode we're going to be looking at the 9618 variant 42 of May, June 2022, and we're doing the Python implementation for question number 2. So here's the question. It says here that a 2D array stores data entered by a user. The main program declares a 2D array of 10 by 10 integer elements. The array is initialized with a random number between 1 and 100 for each element. Write program code for the main program. So let's go ahead and look at the implementation that I have going on here. So I'll scroll down to my main function. So we have the function definition, of course, line 32. Then line 33, we actually have a list comprehension that we are using there. So you remember that for you to declare a 2D array, you actually make use of list comprehensions in Python. And this is how you declare a 2D array in Python. So it's going to be initialized with it's going to be 10 by 10 with values of 0, as it were. Then it's of course it's going to be called array data. Then the next part that we need to address is to actually populate each of the elements, or rather assign a random number between 1 and 100 for each of the 200 elements, as it were, or rather 100 elements, as it were. So here we are making use of two nested loops because remember, a 2D array is essentially going to consist of rows and columns. So we need one loop to iterate through the rows and another loop to iterate through the columns. That's how we can actually access the individual cells in the 2D grid, as it were. And of course, we are making use of the random class or random library. So you see that I import random right here. And then on line 37, we are now making use of the randint function that is found inside of the random module. And we are generating a random number between 1 and 100, as it were. So each of the individual grids, as it were, or positions in the array are going to be assigned a random number between 1 and 100. Then, of course, you'd go ahead and copy the code and paste it inside of the evidence document. Then moving on to the next part here, we have the following bubble sort pseudocode algorithm sorts the data in the first dimension of the 2D array into ascending numerical order. So here we have the pseudocode implementation for that. So we are to amend our main program to implement this bubble sort that's given here. So essentially, we are supposed to translate this from pseudocode into Python, as it were, since we are using Python for this video. So you must not use any built-in sorting functions in your programming language. So it's very important to follow this instruction when they tell you that explicitly that you shouldn't use any built-in functions. You shouldn't use any any built-in functions, as it were. So let's go ahead and look at that. Yeah. So I always reiterate that it's quite easy whenever you see questions like this one. Basically, you're just translating everything line for line, as it were. But you just need to remember how you do it for your particular programming language, as it were. So here you can actually see that you are going to start by initializing the array length to 10. Then, of course, our array is already equal to 10 because that's the size that we did give it here inside of array data. Then we have the for loop that's going to run from 0 up to the array length minus 1. Then for the inner loop, it's going to be array length minus 2, and so forth and so on. So really, you're just taking everything word for word, or rather line by line, and translating it to your programming language equivalent. In this case, we are going to be converting it to the Python equivalent, as it were. So what I did in my case, in order for me to decongest my main function, I actually have this code going on outside of the main function right here. You can actually do the same thing if you find out that your code is no longer getting organized. So I had to decongest it, as it were. So essentially, this is the implementation. So you see that we have the function definition there. Then the length of the array initially, then length of array minus 1, length of array minus 2. If you just look here, you can actually see that we are translating word for word. So you can actually see the three nested for loops there. Then we have that conditional going on right here, checking to see if array data positions x and z is greater than x and z plus 1 there. So you can actually see that right there on line number 9. Then we also do the same thing for the swapping. So the good thing about Python is that you can actually swap things in place. Like for instance, if you wanted to swap, all right, maybe let me just type in an example real quick. Let's say we have, let me just come out of this loop here. So let's say we have a being equal to 2 and b being equal to 5. Then if I wanted to swap a and b, I would actually just type something like this. So in Python, this is very valid. So essentially, it's just going to take the values for a and put it in b, then the value for b is going to be stored instead of a. So that's what we are essentially doing right there on line 12. Is it? So you can actually see that we are taking the element that is right here and we are going to store it on the next index position. Then the value that was on the next index position, we then swap it and put it at the previous index position as it were. So again, if this is complicated to read, just look back to this example right here. So that's effectively what we're just doing. We're just swapping places as it were. So let me just get rid of this because I no longer need this for my solution. So of course, you would go ahead and copy the code and paste it inside of the evidence document. Then for item 2, we have to write program code for a procedure to output all the values in the 2D array. The values should be output as a 2D grid with values in rows and columns. So you remember what I said earlier about a 2D array being like a table or a grid as it were. So let's go ahead and look at this implementation that I have going on here. It's actually inside of the right here, B item 2 just after the bubble sort. So you see that we call this one, we call the variable, rather the function output 2D array, and it's taking an array element as it were. Then we are now iterating through the rows as it were. So basically we are just printing, you have to make use of 2 rows, one for the row and one for the column in a row, sorry, for the value in a row. One for the first loop is for the rows in an array, then the second loop is for the value in the row. Then we are printing that value and we are putting 3 spaces so that we put an extra bit of padding at the end there. So you can actually see when I run it, actually, I think that it makes more sense when I run it. So let me just clear out of here and change this to question 2. Okay. We should be calling output somewhere here. Let me come back here to code the procedure before and after your bubble sort, then test your program. That's the third part of the question. So let me come here and I can call output to the array, then I will pass the array data, array as it were. Then I also have to call it after, later on we'll call it, but for now let's just go ahead and run this. So maybe what I can do for now, I can just, because I have a complete solution as it were, so I can just comment out of this, pull up the terminal, then run the script there. So you actually see that the 2D array gets printed right here, is it? So you see that we have these, the rows and the columns going on as required. I think these are actually random numbers. So if I were to run this a different time, you actually see that is a different, the values are different, as it were, because these are random numbers. So having done this, you can go ahead and take a screenshot of your output and paste it inside of the evidence document. So let me just uncomment these 2 lines here, then go back to the question. So testing your program, that's where you take the screenshot and output it to the, rather than paste it to the evidence document. Then here we now need to implement this binary search. Again, for this question, we were given pseudocode, and our task was simply to translate the pseudocode into a program code as it were. So again, I'm not going to go into detail about how you can implement a binary search. I do have other videos on my channel that you can actually go ahead and check out if you want to cover the binary search algorithm in more detail, especially if you want to do it in Python. So I'm just going to walk you through the implementation here. So here we have the implementation for binary search. So I'm just going to focus on the empty parts as it were. So you see that we have the arguments. We are passing search array, lower, upper search value, just as they have right here in the function header. Then this function is going to return an integer. So maybe I might as well just annotate here that it's going to return an int. Then again, when you are given pseudocode and you are translating it to program code, you are just going to be doing it line by line, as it were. So you just have to know how you do it in your specific language. So in this case, you have to know how to translate pseudocode into Python. So this is the translation for the mid line right there, where we are slicing. We have to we are dividing by 2. Because remember, the div function in Python actually it performs integer division, and to perform integer division in Python, you use 2 forward slashes, as it were. Then we have that if statement going on there. Then we are checking to see if mid is equal to search value, then we return the mid value. That's how binary search works. Otherwise, we are simply going to continue and call binary search recursively, just as they did in this particular instance, and continue in the alternative situation whereby we haven't found our element, as it we can then run this else statement, as it were. Again, really, this is just translating pseudocode into program code, and it's best done, or it's easier to do if you really know how to translate or to interpret pseudocode into your programming language, as it were. So in this case, you should be able to translate pseudocode into Python. So having done that, we ultimately return -1 should we not find what we are looking for. But otherwise, if we find what we are looking for, we are just going to return the search element, as it were. And take note also that this is actually called a recursive implementation for the binary search, because it's the binary search function is actually going to call itself with updated values given the situation that would have arisen for each of the different runs, as it were. So it's going to keep calling itself until it finds the element that it is supposed to search for. Then, yeah, after doing the recursive binary search implementation, you can go ahead and copy the code and paste it inside of the evidence document. Then in the main program, we are to test the function binary search twice, outputting the returned value each time. One test should be for a number that is in the first line of the array. One test should be for a number that is not in the first line of the array. So we have to take a screenshot to show the output, as it were. So let's see, this is actually the last question. So let me just pull up the terminal. Then I'm actually, since we are going to print that grid, I might actually just expand this and run this right here. Okay, we're getting that. Okay, we're getting a traceback. Why am I getting a traceback? I think I might have tampered with something in my code there. Found element that. Alright, I'm actually using these values here. Let's see the traceback. What is it saying here? Line 50, previous line repeated 994 times, maximum application depth exceeded. Alright, that's to be expected. Let me just go ahead and run it one more time. I'm actually getting the same error again. What's going on at line 50? Maybe let me just pause the video and fix this real quick. Alright, so after some soul searching, I found out the part that was giving me the error, as it were. So maybe let me just zoom in here. So the part that was giving me problems with the recursion error was this line right here. Right. So what was happening here was that this original calculation, it's not correctly calculating the midpoint, as it were. Basically, what was happening was that it was causing the mid index to be miscalculated, then leading to cases where the recursion didn't narrow down the search range properly. So that's why you were seeing I was getting that recursion error, maximum recursion depth reached. So basically, it was resulting in a Stack Overflow, as it were, due to the infinite recursion that was going on. In other words, it wasn't converging eventually. So that's why I was getting that error there. So I had to comment out the original implementation that I had done here. It's actually still the same thing, but the only thing that I changed here is this line 23. So it's been replaced by that line 34 there. So I had to remove that negative sign, that negative -1 there, so that it now gives me a midpoint that actually converges, as it were. So alternatively, what you could do is you could actually say mid. Let me just make sure that is a comment there. There's an alternative way. You can say mid is equal to then int, then you can say lower plus upper minus lower, then you divide by 2, then whatever the result is simply going to be typecasted to an integer, then stored as the new midpoint. So this is the alternative implementation that you could do. But I thought this was a bit complicated. This one is much simpler and it gets the job done. So yeah. Then for the output, of course, initially when I ran it, let me just, if I can just scroll here. What's happening with my, you can seem to scroll. Oh yeah, there we go. So initially when I ran it right here, I didn't get the value that I was searching for, because here I actually passed 66 and 84 as the search values. So in the first run, there was no 66 in this first row here. So that's why it gave me -1 and -1 indices right there. But when I ran it around the second time, I actually got the value 66 right there. So you can actually see that it's at index position 6. Then fortunately for me, the number 84 wasn't randomly generated in this first line. So that's why I got a -1. So what you might actually need to do, since these are random numbers, you might actually have to perform several runs until you get the value that you are searching for is generated, as it were. So it's more like a lottery, but really it doesn't really take much time, because I actually got it on the second run. You can actually see right there that I actually got a hit on the second run. Then of course the second number was a miss, which is exactly what we want according to the question right here. Right. So yeah, I think that's just about it for the implementation of this question. I'll see you in the solution for question 3.